So yeah, I've been a developer for a long time. I worked on projects as consultants, and I had enough of projects and changing requirements and not always great customers and bad managers, project managers. So now I'm a developer advocate. So I don't need to deal with all this crap. I only need to deal with you. And if you're not happy, that's fine. I will never know, though. That's fine. As you can see, I'm a bit old. I'm a bit experienced. So when well, it's not funny. You should always tell positive stuff. I'm experienced. When I started to work, actually, we had this thing called monitoring. And in the time, monitoring was a bunch of people sitting all day long in front of a big wall of screens and looking at dashboards. And when the dashboard showed something not good, then they would type and they would log to the machine and they will try to fix the stuff. That was the state-of-the-art alerting. You had monkeys basically watching screens. But the thing is, it doesn't work like this anymore because our systems are more and more distributed. I won't talk about microservices. I will avoid this word because it's very tainted. I think most of the time people are doing microservices for the wrong reason, or not doing microservices but pretending they do anyway. But it's not denying that the systems are more distributed. I mean, when you have a cache, it's already a distributed system. And then it doesn't work anymore. So we need more than just monitoring. So we came with a new word because we like to invent new words, and this word is observability. So I just copy-pasted the explanation from Wikipedia because I'm super lazy. And it mentions, where is it? Yes, it mentions logging and tracing. But it's more than that. It's 3 pillars. Observability is built on 3 pillars. My talk will mainly be about tracing, but still I need to mention metrics and logging, and I have a few slides for each of them. So metrics is actually the thing that we are already doing, that the monkeys in front of their computer were watching all day. They were watching dashboard of metrics. You probably already do it. You probably do it well. The only advice I can give you is to just give higher level metrics, metrics that are closer to the business, because let's be honest, the business doesn't care about the memory usage or the disk usage. They care about, I don't know, the number of order per seconds and this kind of stuff. So you can use the same tools, you just need to aggregate different data and give it to the business, and you will be fine. Logging is a bit more involved, so I have several slides about it. I had a whole talk dedicated to logging, so this is a very short sum up. The first question is what to log. When I was a young engineer, I was working on the JVM, I thought, oh, there is this cool stuff named Java agents. So I will use a Java agent to log so that the developers, because the developers were dumb, right? I was the only smartest one. They logged on this shit, so I will be doing the log myself through a Java agent, and I will log all the input parameters and all the return values. And I will be very smart because then they can not log at all, and I will be the savior of the day. And then I understood that when you log the password, because it's an input parameter, it's not a great idea. So back to square one. You need to actually log your logic in a smart way. So you are actually paying your developers to code the business logic, but you also need to pay your developers to write smart log statements, and that must be manual. So when you're doing the code review, you need to put as much effort in reviewing not only the business logic and the performance and all that stuff, than the log statements, which is stupid, but very, very important, especially if something goes wrong. The logging format we have been using, who here is a Java developer? Yeah, log4j, slf4j, log4j2, yeah, and for ages we have been doing that, and we have been writing human-readable messages. But the thing is, we have been writing human-readable messages because previously, when something went wrong, you went to the machine, you logged, you SSH into the machine, and you read the log file. And it made sense to have human-readable messages because it was for humans. Makes sense. The problem is nowadays, you don't know which machine to log to because it's a distributed system. So the log is not only in one place, it can be on separate machines. But worst case, the machine on which the log was written might already be gone because it was a container. So it doesn't make any sense. So what most people do, if you are smart, you have a log aggregating components, Elasticsearch or whatever, where you put all the logs. What do you need to do to send the logs to Elasticsearch? You need to grok the human-readable-like statements into JSON, which adds an additional component to the grokking and is more fragile, and it takes a chunk of your performance away. Why don't you write JSON directly? Who is writing JSON directly? I knew it. That's why you were my best colleague. So now, tomorrow, well, not perhaps tomorrow, it's Sunday, but on Monday, you need to change your way. You need to remove this grok component and log JSON directly. Your business, your project manager will love you. Where to log is something also that has changed over the years. When I started to work, it was forbidden to log on the console. It was forbidden to use system.out.println. No console, you only write in files. And nowadays, you are using Docker containers. Why do you write? On the console again, because you don't want to mount multiple volumes and whatever. So it changes all the time. Other considerations that you need to take into account, does your application pushes the log, or there is a component that actually gets the log from your system? Both have pros and cons. I mentioned the parsing of the log. You shouldn't parse the log. The log should already be structured. You need to think about where to store the log, for how long to store the logs, how you get rid of all logs. You might have auditability requirements or not, and it's super expensive, for example, if you're using Datadog. And then how to search and display the log. So here, there are lots and lots of systems. As I mentioned, I'm more familiar with Elastic, but basically this is state of the art. I think it's a good overview of the ecosystem at the moment. And finally, tracing. And again, there is a nice Wikipedia explanation, which I don't like. So I have come up with my own. And basically, the idea is distributed tracing is a way to trace a single business transaction in your system across several components. And that's something that is not that new. Actually, there were already those three players doing that, but not many organizations do implement distributed tracing. And one of the reasons so far it has been proprietary. So you chose Zipkin, for example, and now when you made technological choices, you had to think, does my stack has a library that supports Zipkin? Or if you choose Jaeger, same thing. And it was a very limiting factor. So we did something better. We need a standard, but not a standard like, you know, this XKCD comic where we have 14 standards. I will come with one standard that will bind them all, and now you have 15 standards. You need to have a real golden standard. And for that, I think a good organization for such an overstandard is the W3C. And there's actually such a specification that allows you to follow a business transaction across several components called the trace context specification. Who knows about the specification? No?
Oh, I heard about it.
You heard about it. I encourage everybody to read it. It's very, very easy. It's 20 pages. Even I could understand it. So the idea is it defines two concepts. The first concept is a trace. So the trace is a single business transaction. So every business transaction has a trace ID. And then there is a span, and span is something that happens inside a component. So if a transaction goes across a component, there should be at least one span, otherwise nothing happens, but there can be multiple spans. And all the spans, they are bound to a trace, of course, and they're also bound to a parent span in a parent-child relationship. So here is a single trace. No, I will do it here for once. It also works there, so amazing. So here I have a single trace, so a business transaction. I have three components, X, Y, and Z. And then I have my spans going through all components. And one parent span can have multiple children spans, but not the other way around, which can be sometimes an issue, but not always. But most of the cases, it's not an issue. OK, great. We have the specification. And it's based on HTTP headers. And well, you don't want to write that by yourself, right? Because you are developers. And developers are lazy. Who is lazy? Yeah. So for that, we have an implementation of W3C that does more. So OpenTelemetry and the specification are actually a Venn diagram that are not complete cycles. OpenTelemetry gives you the tools to implement the specification, especially you have APIs and SDKs, and a couple of other tools as well. The good thing is that it's a merge of open tracing that I've mentioned in Zipkin and Jaeger, and open census. So it's one of the few times where actually projects, open source projects, merge successfully. Very, very good. It's a CNCF project, and right now everything must be a CNCF project to be successful. It's licensed under the Apache v2 license, and it probably has more followers on GitHub. I didn't update it. It's a black hole. You can think, my opinion is that OpenTelemetry is a black hole. If you are a provider of metrics and traces and logs, you need to implement OpenTelemetry at the moment. And what it does, actually, it specifies two important things. It specifies the OpenTelemetry protocol and the OpenTelemetry format. So you have a bunch of providers. As long as they implement this, then you can send it to an OpenTelemetry collector. And the idea of the OpenTelemetry collector is OpenTelemetry project gives you an OpenTelemetry collector that can actually read and transform and write into whatever you want. But anything can say, I am an OpenTelemetry collector if they actually are able to receive OpenTelemetry data. So the idea is right now, for example, Jaeger and Zipkin, you don't change them. You already have them. And they say, oh, you have a switch. And they say, oh, I accept OpenTelemetry data on this port. And now you can send them OpenTelemetry data. Meaning you don't need to change your infrastructure. You just need to change the way you send data and just enable the switch if you are using Zipkin or Jaeger. And from this point on, you can change your provider. Because once you use OpenTelemetry, then one provider is the same as the other to the exclusion of like how data is stored. So some of you might prefer to have long-term storage for traces, then you will optimize for that. Some other might have other requirements and then might optimize for something else. So I assume most of you are developers, right? Because it's like JavaDay Lviv. So how does it work for you? How can you help your ops colleague have traces. There are two ways to do that. The first question you should ask yourself is, does my tech stack has a runtime? If your tech stack has a runtime, such as Java, then you can do auto-instrumentation. Auto-instrumentation is you don't need your developers to change anything. You just add a Java agent, and everything will be magical. You don't believe me? I will show you. Who is not believe me? You don't believe me? I will show you that you are wrong. You should always trust the French. The other way is manual instrumentation. And now you are giving your developers the API. They need to have an additional dependency, and they need to work. But the good thing is you can have both of them at the same time. You can start with auto-instrumentation and then do it like shadow IT. You do it without telling anybody, and it's not expensive at all. And then you can show it to your manager saying, hey, we managed to fix this bug, or we managed to highlight this problem with OpenTelemetry. Now we need more details. And now you can have a budget, and you can do manual instrumentation. As I mentioned, you should probably do auto-instrumentation by default, because you don't need your developers to be bothered, and it's pretty cheap. So now the demo. It's not your grandmother's demo, right? This is pretty involved demo. So here I have an e-commerce shop, sort of. At least I have an e-commerce API. So I will ask for the product on the front page. I have an API gateway that will forward it to my first component. My first component, because I've been a Java developer, but now I love Kotlin, is a Spring Boot Kotlin component. Amazing. Then it will return it will read the database, get the product, but it needs additional data. The first data that it needs is the pricing. So I will ask another component to give me the price for the product. And it's a Python Flask application. Any Python developer? Well, you feel alone, right? Okay. And then I need to have the stock. So I ask the inventory. But the inventory is actually across several warehouses. So here I will forward it to a single API gateway, an internal one. And then I will ask another component, also in Kotlin and Spring Boot, but for Olga, it's GraalVM native. You like it, I knew it. And here I have another component, a warehouse component in Go and Gin Tonic. Who is a Go developer? Yeah. Yeah. I knew it. So you're not my favorite colleague anymore. And here I have a Ruby Sinatra 1. Because I've been asked a lot of times, oh, but it's based on HTTP header. How does it work with asynchronous communication? What does it work with if you use Kafka or MQTT? So I have added an additional component here, so I can show you how it works. It's more manual, but it still works. And because I want to show you how it works also with some out-of-the-box component, I have added a Redis cache. It's not bad, right? Yeah? I can show you like real stuff. So the first thing, the most important component is the first component, because it's the one that generates the trace ID. And in this case, the first component is an API gateway. And because I'm working for an API gateway, I have one slide about the API gateway. So you can use anything you want, but I'm using Apache APISIX. Who knows about Apache APISIX? Yeah, people I've talked to, that's good. So Apache APISIX is an API gateway that is based on Nginx. Nginx, who knows Nginx? Yeah, a lot more. Wow. Nginx, very good reverse proxy, very mature, very stable. But if you use the open source version and you need to change the configuration, sorry? Restart, yeah! And when the reverse proxy sits at the entry of your information system, it's not super great if you need to change the configuration often. So for that, we have something called OpenResty. OpenResty is a Lua JIT that allows you to change the configuration to hot reload the configuration. That's very good. The problem is that the configuration of OpenResty maps exactly the configuration of Nginx. So for real project, it's not super maintainable. So APISIX offers abstractions, reusable abstractions, so a route, an upstream, a service, and everything is plugin based. So this is the configuration. I can show it to you on the demo. I will start the demo because it's a huge demo and it takes a bit of time to start. Not this one, you don't need this one, you need this one. And I will also explain everything. So Docker Compose down because I'm not sure the state I left it in. It's not, it was sleeping. Up, okay. So here, there should be everything in this Docker Compose file that I have described to you and more. So first thing, I'm using Jaeger as the trace storage. Not because I love Jaeger overall, it's because it's super simple to set up. I use the Docker image, I have one environment variable, I switch, and it's now OpenTelemetry compatible. I love it. I have the front Apache APISIX image. I have the catalog, so the Spring Boot Kotlin stuff. I have the pricing in Python and Flask. I have the inventory in Rust. And I have my internal API gateway to handle all the warehouses, the Go warehouses, the GraalVM warehouse, the Ruby warehouse, and Postgres and Redis. So let's try a simple curl request. Products. 2. Let's do it. Great. So I want to show you how it looks like. That's amazing, right? That's amazing. I have the single business request across all my components. I've got all the spans. So here, as I mentioned, the first one is the most important. This is the entry point. And actually, what is very, very important in this case is not this one, it's this one. It was the first one that was important. It's the sampler. Because probably in real production scenarios, you don't want to trace every single request. You don't have to have millions of business transactions in your storage. You need to sample. Here it's a demo, so I have sample always on, but you probably shouldn't. You have additional attributes. So here you can see that you can have attributes inside every span. So they are by default. Some of them are already, I'm sorry, it's a bit small, but the screen cannot be bigger. And if I do this, I'm not sure it will be much better. So you already have a couple of out-of-the-box information. Here I have added the remote address. So you can see here the remote address, the IP I'm calling from. And here you can also use like Nginx variables. So here, let's say I have an additional variable. I say x. No, not x, h for header. And I say x hotel key égale hello JavaDay Lviv. Great. If I get back here, I should have a second trace. And here, hello JavaDay Lviv. Thank you. There is one guy who understands he should clap every time. The same guy who does Python. There might be a correlation. I have chocolate for you. Everybody should do Python. Anyway. Sorry? Who said something? Who wants chocolate? He was first, I'm sorry. But it's good. And next time. So the API gateway forwards it to the catalog. The catalog here you can find like default internal spans. Then you see all the call stack, right? So let's see how do you do that, because it's really magical. So I'm using the catalog first because you are a Java developer, and though my stuff is in Kotlin, it's pretty similar. Who here is not a real Java developer, but a Kotlin developer? Be proud of it. Wait, how do you like Kotlin? No, you love it. Because everybody loves Kotlin. I love Kotlin. You should love Kotlin. Everybody should love Kotlin. Anyway, that's my POM. So Kotlin, obviously. But you see, there is no dependency to any OpenTelemetry stuff. No dependency at all. So the developers, they code their business logic very happily, and you don't bother them. But now at runtime, or here it's about Docker, so at build time. So this is a multi-stage Docker file. Everybody knows about multi-stage Docker files, right? So the first stage, I'm actually compiling. The second part, I'm packaging. I'm like running. And here I add an additional jar, so I copy it to my image. And when I run the stuff, I run it with the Java agent. You already have your chocolate, so that's fine. Because you clapped, I can show you the Python stuff. It's the same. So in the like poetry stuff, I have nothing OpenTelemetry related, but here in the Docker file, I add the stuff. And just so you know, so I add everything from the poetry stuff. I manually add the OpenTelemetry, and here you have these OpenTelemetry bootstraps. So basically, it goes through every dependency that you have. It checks if there is an oh, you know the trick there. If you know the trick, why are you attending the talk? I was so happy when I found that. I was like, wow, it worked. So it goes through every dependency. It checks if there is an OpenTelemetry component for this dependency, and it adds it manually, and it's just amazing. Now, I don't like it so much, but I can show you the US stuff in Go. And the problem that in Go, and now I'm so bad in Go that I don't find what I want to show you anymore. No, it was this one.
But you have a Go developer here.
Yeah, that's why I have two Go developers. So I'm more familiar with Rust in that case, but who is doing Rust? Okay, that's what I thought. Nobody gives a shit about Rust. Okay. So Go has no runtime. So well, it has a runtime, but in this case, it's not a real runtime. I cannot do the same trick. I cannot pretend that I will add something at runtime. So I actually need to add the dependency and like call the API myself, which is not that great. But still, it's better than nothing. Okay, that's pretty good. Now we can do a bit better. Oh no, I forgot to talk about GraalVM. Oh, I wouldn't be so happy if I don't talk about GraalVM. So here, I have added something else. I'm using, because Java agents are not compatible with GraalVM, right? You cannot, like, everybody is familiar with GraalVM native? Who is not familiar with GraalVM native? You did a bad job. There is one guy behind you who doesn't know about GraalVM native. So the idea is, instead of having a runtime, you compile everything to native code. Now you are bound to a platform, but you don't need a JDK to run your stuff. You can run your stuff directly. And the problem is, like Java agent is a runtime concern, right? You just tell your Java A, like run this jar with this Java agent. So in this case, I cannot use the Java agent, the generic one. So I'm using specific libraries. And in this case, I'm using the micro method tracing and the tracing bridge to OpenTelemetry, and also the exporter to OpenTelemetry. And then it works exactly the same way. But I have no Java agent. the first step takes ages because GraalVM native, right? But the second one, I can use a very small base container image that is very, very like limited in scope and functionality, but also in size. And I run it as a regular executable. But still, I've got some interesting results because it's called warehouse EU. And here, not here. I can see the warehouse EU here. And on the code itself, I don't need to write anything. So it's not real auto instrumentation. I don't use the API. I need to add the dependency, but actually micrometer tracing does a good job at inferring what I want to trace by default. So it's the same as the Java agent in another way. Okay, this is very Jaeger specific, depending on like where you are storing your traces and what UI they propose. You will have different features, but this one is pretty good already. Something also, even if you are not a developer or an ops or whatever, you can see some interesting stuff. For example, here, I'm calling, the catalog calls the inventory directly, but it calls the pricing through the API gateway. So in some cases, you want better performance, so you call it directly. Some other cases, you want to have additional security, so you call it through the API gateway. But here, as an architect, I would ask the question, like, why are you doing it in one way on one case and the other way in the other case? So it also helps you as an architect to understand what happens for real. Last but not least, so there was one guy who is a Kotlin developer. Who here loves to do concurrent programming? But you are a Kotlin developer, so you are using coroutines all the time.
Yeah, but
no, you are cheating. Go routines don't count.
why?
Because it's Go, it's bad by default. Okay, but you love concurrent programming because Go routines helps you. And I'm a JVM developer, and I don't want to think about executor service or threadings or all the. It's gone, and it's gone. But you still hear me, right? Because I have a strong voice. That's fine. And here you can check that actually the calls are in parallel. So normally I should have a call to the inventory here and a call to the pricing somewhere here, and they should be more or less parallel. I don't see them, but they should be parallel. And the reason for that is on the Kotlin side, I have these stuff here, and I am using coroutines. I don't remember where they are, so 2 seconds, please. Yes, async here and async here. Because Kotlin makes parallel programming so much easier. Okay, so everything has been pretty easy so far, but let's say that I want to have more details using Kotlin, using the JVM. So I want to add additional details through manual instrumentations. So I will do that with the next stuff, which is here, checkout. And I will up it here. And now I have added an additional dependency in my Java app, which is the annotations. And now I can add additional spans by annotating them with span. So the Java agents didn't discover them previously. By default, the span will be named with the class name and the method name, but you can override it here. It's perhaps a bit small here. And as for the API gateway, you can add additional data. So you can pass in the parameters list, you can like annotate it with span attributes. You can name it how you want, and it will get traced as well. So if we do this and we do again this one. Oops, not here, here. I will leave it here. I will localhost there. What did I want to show you? Yeah, the additional traces here. So here you have additional traces. The fetch was not there before. And I didn't mention it, but by default, you get like the, how it's called again? The Spring Data Reactive repository instrumented by default with the agents. You've got, if I remember well, there is the REST client that is instrumented as well. But here, this one is something that I did by myself. This one and this one are by myself. I did it on purpose. So it's pretty good. And also, yeah, if you're using Postgres, for example, here in Python, you already have the connection that is instrumented by default, although I didn't do anything. And here with Redis, you already have the set of the Redis because you are using the default driver, which is Lettuce. So it's pretty good. Annotations are very nice, but we can even go further. How long do I have? More than 15 minutes. It's really, really nice. Then I can go to the last, and I think the most important one. What if what you want to use doesn't support OpenTelemetry out of the box? So as I mentioned, here we didn't care about the HTTP header. The libraries that we were using were actually reading the HTTP header and putting it into another span with the same trace ID, with the span parent ID, and sending it to OpenTelemetry. We didn't do nothing. It was super easy. Now, I want to have analytics. So I want to have an MQTT queue that actually, when I call the API, will pretend to log some analytics and store it into the MQTT queue. And on the other side, we will have these TypeScript components with Node.js that will actually read it. And that there is no library for that. So what can we do? Well, we can do everything manually. And that's a bit crappy, but it still works exactly the same. So here, I do it again. And now I will have another trace. And we have 9 components here, 9. You can see another component called analytics. It's very small. Look, very, very small. We have one additional span called filter. And how does it look like? So this is the main catalog. No more GraalVM, I'm sorry. But it still works the same way. We have this analytics stuff. So the analytics stuff is a filter on the reactive API. So how do we implement it? So I'm using the Kotlin DSL, so I don't use annotation that much. I'm sorry if I disturb some of you, but that's one of the main benefits for me to use the Kotlin DSL, is that everything is very explicit. So I have this co-router, so I have all my routes here that are inside a co-router. Normally it would be a router, but I'm using coroutine, so it's a co-router. And I will apply for everything, I will apply this filter. This filter, I pass it the MQTT client to talk to MQTT parameters, and also I pass it the global instance of OpenTelemetry. So this API allows me to get a handle on the OpenTelemetry instance. And at this point, I can, not here, I can do crazy stuff. So now I have the API in my dependency. That's one of the first things I should show you first, is not only I have the annotations, I have the API here. So now I'm in full control of what I'm doing. So instead of letting the Java agent or the annotations do their stuff, I can actually build the tracer myself. So here is the OpenTelemetry instance. I can have a tracer, and from the tracer, I can actually build a span and start the span. What do I put in the span? Well, something that are not very important. Here is what is the important stuff. Message holder. Message holder allows me to send the trace parent. So this is the value of the HTTP header that you never see, that you never saw before. I reconstruct it, and then I send it as metadata in the message. So there are two choices here. Either you have an advanced version of MQTT, you can have metadata. If you don't have metadata, well, you send the metadata is in the JSON regular payload. It's not metadata anymore, it's part of your message. But anyway, here I'm able to do that. And I create the JSON, everything is fine. And here, so here I start the span, and here I end the span. When I actually end the span, it means that the app will send the message to OpenTelemetry, to the collector, with the data that it collected. The rest is not that important. And on the TypeScript side, here, sorry, I'm not used. So you have the regular different events on connect, on reconnect, but the important one is on message. So I check if it's on the right topic. I get the payload, which for our case is not important, but now I get the user properties. So I'm reading the metadata again. So now I'm able to get the trace parent. And then, because I have the trace parent, I can use it. So here I'm using from the client of the queue, I'm reconstructing another trace and another span that will have the trace ID from the caller and the parent span ID. And here, of course, I'm just like starting the span and ending the span because I don't do nothing in between. But that's how it works. And we can see something also interesting if I stop the component. So I will stop Docker, compose, stop analytics. So I have stopped the MQTT clients. If I do a call again, so here you don't see the analytics components because it's down, but it doesn't stop from seeing you from seeing all the rest. Now, if I start it again, what happens? It will pick up the message and it will send the final span to OpenTelemetry. 21 now. But of course, now the scale is very different because everything here is in milliseconds, and then I stopped several seconds to talk to you, and then we have the rest there, microseconds. So even if some of the components are failing, you can see the whole stuff. You can also see some errors or whatever. And that brings me to the end of my talk. Unless you have questions. Yes?
So I have one question. In your code, you do span.end.
Yes.
And you say that we send a request to the OpenTelemetry. But my question is this a blocking request?
No.
So it will be sent at the background, right?
Yes. And it depends on the implementation. It depends on the implementation, how it will be sent. It can be sent in batch. It can be sent asynchronously when there is time. I don't care about it. Yes?
Yeah, you showed us that this OpenTelemetry magic does all the thing magically with fast times, right? But with messaging, we have to do that thing manually. Why? Is that because something is not implemented and it's possible to implement?
You can do it. I mean, whatever I did manually, you can do it like in a library. It's just that at the moment, people are super focused on like REST calls through HTTPI because it's how it's supposed to work. But otherwise, you can implement your own library, and I would encourage you. But then you remember, like it works across several tech stacks. So if you do one in Java, people in Python wouldn't benefit from it, so they would need to develop their own.
Yeah, also another question about multi-threading.
Yes.
For example, yeah. So most of that sync, I think, works based on the thread local, right? So it has the context in one thread. What about like?
For this reason, I'm using the reactive stuff. So here, if you can see my palm. I'm using Webflux. So there is a high chance it doesn't use thread local.
But what about the case, for example, if we have some Java API endpoint, yeah, that inside just calls like some executor service, right? Just running another thread, and we want to log also that messages inside of it.
Either it's implemented by the library, and then you need to read the documentation, or you need to be very careful, because yeah, you will need to actually extract the.
Extracting them in the thread.
Exactly. What the library does is exactly what it reads the HTTP header from the request, and it creates an additional span, and it passes it down the further calls. That's exactly what it does. So because I'm super lazy, I prefer to use the library. But if it's not implemented in your specific use case, then this is what I showed you using the MQTTQ. You do the same manually. Yes?
Yeah, as an extension to this question, so you were showing annotations.
Yes.
This span, and this looks great.
But.
You were putting them on the.
Nothing happens before the bot. Starts directly after the bot.
Right. So that library that you were using for annotations, is it generic or?
Yes. So the Java agent is generic. And that's funny because I'm using version, let me check because I don't know it by heart. My catalog is here, Docker file. Yeah, I'm using version 2 something. So there was a breaking change, well, not really breaking change, but at the end you had different results between V1 and V2. V1 was super eager to like actually try to instrument everything that was Spring related. V2 does the minimum, and it's up to you to add your additional spans if you want them with span.
So basically, if I have a regular Spring application, right, no Webflux, I can use the annotations right away.
Yes, it will be completely. The thing is, for example, I think I didn't check, but I think the Java agent works with Quarkus or everything. The Java agent is actually so generic. Actually, it's not generic, but there is the logic for a lot of library inside. So a lot of the code that is in the agent is actually not used for your application. But it does a lot, actually. So if you have a regular web MVC application, it will work. The code will look exactly the same. It will be different dependency, different imports, and boom, you're done.
It's just very powerful concept where you can just enrich the content with annotation, because it's great.
Sorry again?
I mean, it's a great concept where you can add an annotation.
Yes and no. So yes and no, and the reason for that is that here, for example, so I enriched it, but I'm passing the product ID. Whereas I'm still already passing the product.
Yeah, of course.
So actually, from a clean code point of view, you are actually changing the signature just for the purpose of adding additional data. So in that case, perhaps the annotation is not a great idea. You should like use the API, unless you have requirements not to use the API because or whatever.
There just may be cases where very like specific place in your code where you really need to see what's happening.
Exactly.
And, yeah, it justifies the price.
Yeah, and that's my point. You can start with like basic insights, and then perhaps ask for more money because, yeah, like if you do it manually, it's like logs. Huh? It's more like expensive, but you can start with basic stuff, and you will get already interesting results.
Okay, another question then.
Sure.
Kind of log.
The talks was about tracing, right?
Yeah.
Okay.
one has its own storage. That's natural, right? Jaeger has its own storage for trace and span data.
Yes.
Like Elastic APM has everyone.
Yeah.
Do you know an example of the APM product that allows you to export, allows you raw access to spans and traces?
No.
No. That's unfortunate.
That's very unfortunate. But that's the thing.
I know one where you can do it.
Okay.
I just did it yesterday.
Okay.
You can do it in Elastic APM because they store these spans and traces in indices,
Mm-hmm.
and you should just query them
Mm-hmm.
and then export a CSV because I need to debug a very specific performance issue with the database, and it doesn't show me enough detail.
I cannot help you on this. I'm sorry.
It's unfortunate.
It's very unfortunate. But that's why you are paid a lot. No, I'm sorry. I cannot help you there. Other questions? Meanwhile, yes, sure. Meanwhile, I can still show you the last slide. So if you want to follow me, because you know I'm a developer advocate, I need to have followers to find my next job. I can show, hey, look, I have this many followers. Please pay me a lot. You can follow me on Twitter, even though it's fucked up now. But because I don't know what next stuff will be, you can follow me on Mastodon or Blue Sky. If you're interested about the demo code, if you want to play it at home, because that I didn't bullshit you, everything is on GitHub. I'm just using a bit.ly link to check how many people did actually open the link, because I know that you are very lazy in general. And even though the talk was not about Apache APISIX, I would be grateful if you had a look. If you need an API gateway, it's an Apache project, so it's free as a beer and free as a bird. And I mean, people pay me to talk about Apache APISIX. So if you want me to come next year with the same employer, I would be grateful. Because it's a great company. Yes?
So let's take into account OpenTelemetry and Dynatrace, and how to properly say what is this and what is that. I guess to say one is specification, another one is implementation.
First, I didn't do Dynatrace for a long time. In my time, it was mostly to actually check performance issues. And OpenTelemetry, you see the same kind of stuff, right? But for example, in Dynatrace, as far as I remember, you could check like every call stack in the Java, in the JVM, which is not the case with OpenTelemetry unless you have added your stuff yourself. And then you can't go into the JVM specific stuff. You can only instrument your own code. As I mentioned, I didn't do Dynatrace for a long time, so I cannot answer you with that.
Looks quite similar.
Yeah, again, they might look similar on the surface, but the implementation will be very different, and the objectives will be different as well. I have time for one more question because the volunteer looked at me very angrily.
It's lunchtime.
Okay, you don't have time for question anymore. I wish you, I enjoy your lunch, and if you have questions,